All right, we are at section 13.4, position, velocity, and acceleration as a function of time. Um, so let's start off with the PowerPoint, and then I'm going to do some stuff on my iPad. Let's see. Okay, position, velocity, and acceleration. As the ball at P rotates in a circle with uniform angular speed, its projection Q along the x-axis moves with simple harmonic motion. And the position of x is equal to a cosine theta. So that's just a is the hypotenuse and x is the adjacent side. So cosine of theta is equal to x divided by a. So x is equals a cosine theta. So the theta equals omega t, where omega is the angular frequency, omega being 2 pi times f, the frequency. There's a difference between angular frequency and frequency. Okay, so x equals a cosine omega t. Now, omega equals delta theta divided by delta t. In other words, theta is the distance traveled, delta t is the time. So whenever you have distance divided by time, you get a velocity. In this case, an angular velocity, because theta is the growth of the angle, or the arc length, if you want to call it that. So a full circle is 2 pi, and 2 pi divided by the period is the period is the time it takes to go around once in the circle. So omega is equal to 2 pi f, and 2 pi divided by t. So x is equal to a cosine 2 pi f t. We will use this when we get to the electricity and magnetism, especially when we start talking about capacitive reactance and inductive reactance. Okay, now let's look at this is 3 graphs. The first one shows you position, a cosine omega t, and then the next is v, the velocity, and the next is acceleration. Now, we had earlier that v equals plus or minus the square root of k over m times a squared minus x squared, all under the square root. And so if x equals a cosine 2 pi ft, x squared is a squared cosine squared of 2 pi ft, and they're just doing that substitution. So v equals plus or minus k over m times a squared minus a squared cosine squared 2 pi ft. Well, we can pull the a out, a from that parentheses, a squared equals 1 minus cosine squared t, and then we can use an identity. 1 minus cosine squared theta equals sine squared theta, and we also use the fact that omega equals k over m, and we get that v equals a omega sine 2 pi ft. So so that's the velocity. Now the acceleration, x equals a cosine 2 pi ft. Acceleration is equal to minus k m over x. So acceleration is equal to minus a omega squared. If omega is equal to k over m, if omega is equal to the square root of k over m, then omega squared is equal to km. And so acceleration is equal to minus a omega squared cosine 2 pi ft, given the x, that x is equal to a cosine 2 pi ft. Now, before I get on to this, I want to go back. Oops, wrong I have auxiliary notes here. Let's stop this share. And this may not be useful to some of you, but anybody that knows calculus will this may help them instead of going through that fancy derivation that they did, which works. Uh, these are your three equations for position, velocity, and acceleration. You see them on the graph also, but here they are nicely, one after the other. X equals a cosine 2 pi ft. V equals minus a omega sine 2 pi ft, and a equals minus a omega uh, squared cosine 2 pi ft. Now, if we call this omega t, this is omega t, and this is omega t. That's kind of messy. Let's make it look omega t. If you know anything about calculus, if you don't, ignore what I'm about to say. But if you know anything about calculus, you know that the derivative of cosine theta is equal to minus sine theta. In other words, the theta is whatever's inside the parentheses. So the velocity is the first derivative of position, and acceleration is the first derivative of velocity, which is the second derivative of position. And that's an easier way to get these. If you don't know calculus, then you have to rely on the methods just used. You're not going to be deriving these equations. They're just for explanation. But x equals a cosine omega t. Take the first derivative of that. You get minus a omega sine omega t. And then you take the derivative of that, the velocity, to get acceleration. You get minus a omega squared cosine omega t. If that doesn't help you, forget it. Just ignore it. But for those of you that understand calculus, that's an easy way to remember. So let's go back and look at that last slide. And if you can imagine just a pendulum going back and forth, and you're going to do this on Thursday, you are going to, I mean, you're not going to do this with a piece of paper, but you're going to see a pendulum going up and down. And you can imagine if you had a scroll of paper that would steadily move across this pendulum, and this pendulum has a little ink, a little pen to write on the paper. As the pendulum bob goes up and down, and the paper scrolls around, you would mark out this sinusoidal wave on the paper. That's just another way of thinking about it. And I think the next we're going to go to it's a pendulum, so we'll stop here.